So in this recording, we're going to be looking at the paper 5 higher, and this is a non-calculator paper. Okay, so question 1, just a fraction question with a division. So when it's a division, I use the KSC method, keep, flip, change. Before we do that, we need to change this into an improper fraction. How do we do that? 1 times 7 is 7, plus 4 is 11. So this is the same as 11 over 7. So we have 33 over 35 divided by 11 over 7. Now we can keep, flip, change. So we keep the first fraction as it is. We flip the second fraction. We're going to change the divide to a times. So now we can just multiply the numerators and multiply the denominators, but it's a little bit of a nightmare. If we're gonna, well, it's quite difficult. Well, we're gonna have to spend some time working both of those sums out. So and then it might be a bit of a nightmare to simplify. So I'm gonna simplify before I multiply. So if you look at like opposite corners, top left, bottom right, they have a common factor of 11. So how many 11s divide into 33? It's just 3. How many 11s divide into 11? 1. I'm going to do the same over here with these opposite corners. They both have a factor of 7. 7 divided by 7 is 1. 7s into 35 is 5. And then 3 times 1 is 3. 5 times 1 is 5. So your answer should be 3/5 because it does ask for it in its simplest form. If you had have just multiplied them, let me just cheat here and get a calculator just to save some time. If you had have done 33 divided by 7, you would have got 231 here. And 35 times 11 is 385. So I'd have been looking at that and thinking, not sure what the common factors are to simplify without a calculator. So can you see it's just easier to simplify first. If you had have done that and not simplified, you would have still picked up some marks. Got angles and parallel lines. So A here, hopefully you've spotted, is 125. It's kind of like an upside down F angle, which the official name is because it's a corresponding angle. Work out the value of B. Okay, so I'd be looking at it and thinking, well, we've got a triangle here, haven't we? Can I get any of these other angles in my triangle? We've got 75. Opposite angles are the same, so 75. And it's the F angle again, corresponding angle, 75. And we've got this angle here. Angles on a straight line add up to 180. So that one's 55. And then you've got angles in a triangle add up to 180. So we've got 55 at 75, 130, 180, take away 130, because your missing angle B is 50. Okay, next question. A division including decimals without a calculator. I usually write this as a fraction first. Whenever I'm dividing by a decimal, I like to write it as a fraction, and then I do not want my denominator to have any decimals in it. So what would I multiply this by to get rid of my decimal? I could times it by 100. In which case, because I'm making an equivalent fraction, I've got to times the numerator by 100. So 380 over 2. Don't have my decimals anymore, so it's not as awkward. What's 380 divided by 2? 190. Okay, so students explain how to work out the value of B. So they've done, we know the base is 2 centimeters longer than the height, and the volume is 240. B is 6, because that means H is 4. Well, that's 2 centimeters longer than this, so yes, that's true. And 6 times 4 times 10 is 240. Describe the student's error. Well, they've worked out the volume of a cuboid. To find the volume of a prism, we need the area of the face times by the depth. This is a triangle here. The area of that triangle is not 6 times 4. So the error is they've not worked out the area of the triangle correctly. Let me just see what they've put in the mark scheme here. So I'll give you all the alternative answers. Half omitted from the area of the cross section. Okay, so half not included for area of triangle. Let me just see if they do have any alternatives here. No, not really. But anyway, they want the true value of B. So we know half base times height times 10 gives you 240. A couple of ways you could kind of think about reversing this, rearranging this. I times both sides by 2 to get rid of this half. Times on the left-hand side by 2, just get rid of the half, and that becomes 480. Divide both sides by 10. Well, I know 8 times 6 is 48. And does that work? Because yes, the height might be the other way around. Hang on, let's just have a look. The base is 2 centimeters longer than the height. No, that does work. So the base is 8. Okay, next we could have done that in a different way, perhaps. But you should have got the answer as 8. 5, a scatter diagram. Plot the points for the remaining 4 children. Now, if you get some kind of plotting points question, I always just make sure you check the scale first. So can we see on the x-axis, the age in years, it's going up in 0.2s. Okay, what about this y-axis? We've gone from 0.4 to 0.5, so that would be going up in 0.02s. 0.42, 44, 46, 48, 0.5. Okay, so 5, 1.14. That's 5. 1.14 is 1.12, 1.14. And that one, 7, 1.24. 7. It's hard to keep a track of this here. 1.2, 1.22, 1.24. 9, 1.26. 1.2, 1.22, 1.24, 1.26. And 14, 1.68. Okay, those are 2 marks for all your points plotted correctly. Describe the type of correlation. Well, as my age increases, so does the height, so it's just positive correlation. One of these children is taller than expected for their age. On the scatter diagram, circle the point representing this child. You can see this one here is a little bit of an anomaly, isn't it? Like this 6-year-old, tall for his age. Doesn't fit the pattern of all the rest of the points. Okay, I'm going to draw a line of best fit here. Let me just snip this over so I can show you how to do this. Points, remember, with a line of best fit does not need to go through your origin, or 0.4 in this case. It's got to be a straight line that follows the general direction of all of your points and kind of has an equal amount of crosses on each side. Yeah, that works. The line of best fit should look something like this. Let me just check the question we're answering here. We want Kai is 8 years old, estimate Kai's height. Actually use your graph to show the marker that you've used, this person being 8 here, and you've read across. So what height are they? 1.2, 1.242, 1.24, 1.26 meters. So describe an assumption you've made for your answer in D part 1. It's kind of like all the children fit this pattern. So look, so the child will fit the average pattern, something along those lines. Explain why using the data to estimate the height of a child that is 17 years old may be unreliable. Can you see in our scatter graph, the age goes up to 14, so it's out of the data range. Let me just see what they put. Yeah, only have data on students up to 14 years old. I might read out anything else that's acceptable here too, because there's quite a lot. The trend may not continue. The line of best fit should not extend beyond the data provided. Outside the range of data, small sample. Do not accept 17 is not on the graph. The graph does not go up to 17. So make sure you haven't written those two statements at the bottom. Okay, so question 6. Taylor has a full bottle of medicine. The bottle holds 20 doses of medicine. Each day, Taylor takes 1 dose of medicine out of the bottle. After 8 days, there are 180 millilitres of medicine left in the bottle. Okay, right. So after 8 days, there's 12 doses left, right? Because he's had 8 doses. Take that off 20. And that represents 180 mil. So I want to work out what 1 dose is worth. So I'm going to divide both sides by 12. Okay, so do a little bit of a bus stop method here. 12s into 1, can't do. 12s into 18 is 1, remainder 6. 12s into 60 is 5. So 15 mil. 1 dose is 15 mil. We've got 20 doses when the bottle is full. Sorry, can't spell. I'm going to multiply this by 20. 2 times 15 is 30. Put my 0 at the end. So 300 mil is your answer here. Volunteer packs boxes for charity. They pack 5 boxes in 45 seconds. Use this information that they can pack 55 boxes in less than 9 minutes. Okay, so 5 boxes, 45 seconds. Well, let's work out 1 box first, shall we? We're saying 1 box, 9 seconds. We want 55 boxes. We want 9 times 55. So it's up to you how you work this out. I'm going to do 50 lots of 9 and then 5 lots of 9 and add them together. So 50 lots of 9 is 450. You might have a slightly different way than me. 5 times 9 is 45. Add them together. 495 minutes. Seconds, not minutes. 495 seconds. So 9 minutes. 60 seconds in a minute. 9 times 6 is 54, so it'll be 540 minutes. I mean, seconds. So we've shown here that this is less. Okay, so what assumption do we make? Something along the lines of, well, they packed at the same rate. Let's just see what we have in the mark scheme here. Yeah, they continue to pack boxes at the same rate. There are some other ones I'm going to read out in a second. Oh yeah, they put all faster in brackets. That would work. So accept any comments here. So something like they took no breaks. They pack for 9 minutes without stopping. Each box took the same time to pack. They don't get tired. That they were not interrupted. The boxes remain the same size and consistency. That they won't make any mistakes. I assumed every box took 9 seconds. The only thing we've got for do not accept here is I assumed one box took 9 seconds. Okay. So I'm just looking at this, looking like it's density equals mass over volume. So we've got a block in the shape of a cuboid. The density of iron is 7.87 grams per centimetres cubed. Sam thinks the mass is 2.4 kilograms. Use estimation to decide if Sam's answer is reasonable. Show how you decide. Okay, so we know the density and we know the volume. This is what Sam thinks, so we're going to work it out by using estimation. So let's get the volume of this cuboid first of all. I'm going to round this to 3, so it's base times height times depth. So you multiply your dimensions together. Length, width, height, however you want to call it. So you've got 3, 5, and 2. 3 times 5 is 15, times 2 is 30 centimetres cubed. Always be careful with your units and measurements when you're looking at these types of questions. Okay, density, I'm going to round that to 8. Let's put in my formula. We know 8. Let's make my mass the subject. So I'm going to times both sides by 30. $240. Okay, well, what are the units here? So because this density was in grams per centimetres cubed, this is centimetres cubed, so this has got to be grams. Okay, so we need to convert this into kilograms. Okay, divide it by 1,000. And 240 divided by 1,000 is 0.24. But I want to put a 0 on the end, it doesn't matter, kilograms. So Sam is incorrect. Because the mass is 0.24 kilograms. Oh, 5 marks for that one. Write down the number of antelope as a percentage of the number of zebra. Well, the first ratio we're given, antelope to zebra. Let's write it as a fraction first. So what is write the number of antelope as a fraction of the number of zebra? Okay, so now we've got it as a fraction. How do we convert that into a percentage? 3 divided by 2 is 1.5. You could have done a little bus stop method to find that out maybe if you weren't sure. And how do we then convert that into a percentage? Times it by 100, so it's 150%. There are 15 more meerkats and antelopes, so we need to have a ratio of antelope to zebra to meerkat, which we do not have at the moment. If you look at both of our ratios, can you see that zebra is repeated? Antelope to zebra, meerkat to zebra. So what we need to do is we need to find the lowest common multiple of 2 and 3, which is 6, to get the zebra at the same amount. So multiply, so my LCM is 6, so I want to make zebra into 6. So if I make this into 6 for zebra, I'm timesing it by 3, so I have to times my antelope by 3. And here, for my zebra, multiply that by 2, so multiply this by 2. So now my zebra is the same, I can write it as 1 full ratio. Antelope 9, zebra to 6, meerkat 14. There are 15 more meerkats than antelopes. But again, so if you think about this as parts, we've got 9 parts for antelope. Got 6 for zebra. We've got 14 for meerkat. Obviously, you don't have to do it like this. I think it's good to show you how to work out a ratio. It's good to see it in terms of parts. So, right, we've got 50 more meerkats than antelope. So what does that mean in terms of our parts? Well, how many more parts does meerkat have than antelope? So 14 take away 9 is 5. So you've got that kind of part more meerkat. 15 divided by 5 is 3, which means every single box in this entire ratio represents 3. And what we're working out, the amount of zebras, so we know each box here represents 3, so 3 times 6, 18 zebras. Okay, so a student draws 2 different regular polygons. The exterior angle of one is P, exterior angle of the other. So this is angles and polygons. There's a few formulas you won't be given these, you'll have to remember them. So angle sum is n minus 2 times 180. Exterior angle is 360 divided by the number of sides. Interior angle is angle sum divided by number of sides, and it's useful to have the exterior plus the interior is 180. So which ones do we need here? Well, hang on, before we do that, we know the sum of P and Q is 112. So P plus Q is 112. The difference between P and Q is 32. So now we should be noticing, well, it's simultaneous equations as well. We've got 2 unknowns here, so how do we work them out? My Q's are the same because so with simultaneous equations, I always look to see are the terms the same here. They are. We've got 1Q, 1Q. But because we've got different sides, you need to add them. In all of the instances, you subtract your equations. P plus P, 2P. 112 plus 132, 144. So divide both sides by 2. P is 72 degrees. Right, now we've got our P. We need to get our Q. It's up to you which equation you use. I'm going to say 72. I'm just going to work this out in my head because it's quite obvious. 72 minus Q is 32. So Q's got to equal 40, right? Because 72 minus 40 is 32. Not finished yet. We've just found our P and our Q. We actually need to work out the number of sides of each polygon. So the most useful formula here is exterior angle. There should be 2 separate words there, but never mind. It's 360 divided by the number of sides. We know our exterior angle here, so let's start with this 40 first. You know that 40 equals 360 divided by a number of sides. So we're just going to rearrange that formula now to get n. I'm going to times both sides by n. I do not want n on the bottom of a fraction, which gives you 40 times n is 360. Divide both sides by 40. N is 360 divided by 40, which is 9. So that's one of my polygons, is a 9-sided nonagon. The next one is, let's just put it in the same formula. 72. Oh, it's not as obvious, this one. Times both sides by n. Divide both sides by 72. Okay, I think I'm just gonna go up my 72 times table till I get to 360. So 72, 144, 216. Could do little addition sums if you can't get it in your head. I'm just adding 70 and adding 2, 288. Hopefully we'll get to 360. Hopefully I've done this right. Yeah, 360. 1, 2, 3, 4, 5. And we've got a pentagon. Okay, y is directly proportional to the square of x. That means that y and x are changing, but I'm just going to write this down. Not sure how useful it is. Find the percentage decrease in y when x is decreased by 30%. So with direct proportion, so usually what you'll find is if y is proportional to x, if x is increasing, so is y, and it's by the same amount. Same with this, but it's not just x, it's x squared. So let's just have a look. So, right, okay. So I'm thinking if we decrease something by 30%, so using a multiplier, that's going to give us 70% of the value, isn't it? Which is 0.7 as a multiplier, as a decimal. So 0.7, 0.7 squared, which gives you 7 times 7 is 49, 0.49. So that would mean if I make that up to 100%, that y is 51%. Quite a tricky question, that. So you may have got some marks. Just check the mark scheme to see if you could have picked up some marks on this, because I doubt many people have got this right. Let's have a look. 51 over 100. If you've got yk equals x squared, or y equals kx squared, you've got 0.49 anywhere. Yeah, it's quite a tricky question, that. Let's move on. Question 12. Here are the first 4 terms of a sequence. What is find the next term? Okay, so the numerator is a linear sequence, isn't it? So we're adding 3 each time. And the denominator, not a linear sequence. It looks like a quadratic sequence. We need to add 11 next. 37. Find the nth term. So I'm going to do an nth term for the linear sequence at the top, then an nth term for the quadratic sequence. So my linear sequence is like this, isn't it? So that's going up in 3s. So 3n, like the 3 times table. I put my 3 times table underneath. 3n take away 1. So that's a numerator sorted. What about this denominator? There's quite a few different ways of finding the nth term of a quadratic sequence. I'm not sure which one you will have been taught. I do it like this sometimes, depending on the exam board, because some quadratic sequences are more complicated. This is quite a complicated one. So I worked out it was 5, 7, 9, which is a difference, gives a second difference of 2, half the 2. So it'll be 1n squared. Then I write out the sequence. So you always divide your second difference to get the coefficient of n squared, if that makes sense. Then I write out the n squared terms underneath. So 5 take away 1 is 4. Then I subtract them, sorry. Should have mentioned that. 10 take away 4 is 6. Now we've got a nice linear sequence here. What's the nth term of this linear sequence? It's going up in 2s. 2n. Got my 2 times table underneath. You might have been taught a different way to this, though. It's n squared plus 2n plus 2. So 3n minus 1. Even if you'd got the linear sequence at the top, you would have picked yourself up some marks there. All right, you need to, so this looks like it's soccer toe and on calculator. So just bear in mind, you need to remember all of your like sine 30, sine 45, cos 30, cos 45, some of your trigonometric ratios. You should have been told in class which ones you need to learn. Right, so work out the length BD. This is my x. We've got opposite here, hypotenuse here, SOHCAHTOA, sine, isn't it? Because it uses O and H. Right, so we know sine 30 equals x over 12. Now, sine 30, I always feel like it's the easy one to remember. Sine 30 is a half, isn't it? So half equals x over 12. Times both sides by 12. 12 times a half is 6. So x is 6. So work out the exact value of, I'm going to just change that to a 6 now. Work out the exact value of AB. So that's x. So we've got a hypotenuse, got our opposite. Oh, so it's only the sine ones we need to use here. So sine 45 equals 6 over x. Sine 45 is root 2 over 2. You need to know that. Right, so I'm going to do like a cross multiplication thing here, I think. So root 2 times x equals 2 times 6 is 12. X is 12, divide both sides by root 2. Now, usually when they ask you to put it in the simplest form, you rationalise the denominator as well. I'm going to rationalise the denominator and I'll check which is fine for the mark scheme. So times both sides by root 2. So x is 12 root 2. Root 2 times root 2 is 2. 12 divided by 2 is 6. So 6 root 2. Let's just see what they will accept though. Oh, right. So yes, you could have got it for, yeah, either one of those. So you could have, if you just put 12 over root 2 or 6 root 2 for your 3 marks. Let me snip this one over as well. The region R satisfies the following inequalities by drawing one more line. Find and label the region R. So obviously this straight line here is x equals minus 3, isn't it? That's fairly straightforward. So the line going diagonally across through here would be y equals x. So this is y equals minus x. So this is the one we have to draw ourselves. So what I usually do first is make y the subject. So I need to add 1 to both sides. Then I just change the inequality sign to an equals. You might do it in a slightly different way, but you can just check if you've got the same answer as me. I create a table. I can choose any values here for x. I'm going to do 0, 1, 2. And I'm going to work out my corresponding y values. Half of 0 is 0 plus 1 is 1. Half of 1 is 1. No, half of 1 is a half. Plus 1 is 1.5. Half of 2 is 1. Plus 1 is 3. I'm going to plot those points. 0, 1. 1, 1.5. 2, 3. I thought something had gone wrong there. Didn't look right. I've not worked this out correctly, have I? Half of 2 is 1. 1 plus 1 is 2. Sorry. Okay. That makes more sense now. Yeah, you can usually tell if you've made a mistake here because you do get. I didn't look right. The line wouldn't have been a straight line, so I knew I'd gone wrong. There's some really basic maths. Right. So here's my line y equals half x plus 1. So I was just looking at that. I don't know why it said minus 30, minus 3. Okay, so people do this different ways. Some people shade the region they don't want and see what's left over. Some people shade all 3 regions and see which has been shaded 3 times. I'm going to shade the regions we want and see which is shaded all 3 times. So we want x to be less than or equal to minus 3. That's all of this section here. Because all of that is less than or equal to minus 3. The rest is bigger than. Oh, just another point here. Let me just check. So this should have really been a dashed line here because it's bigger than. Let me see. Oh, yes, you do. Yeah. So some exam boards, you don't lose any marks for not having a dashed line here. So this should be a broken up line. I'm going to have to draw it again, which is going to be kind of hard to do. I'm going to have to just do it like this. So because I can't get, okay, it's going to be something like this. You should be able to do easier with pen and paper. So make sure that's a broken up line. It's because it's just greater than and not greater than or equal to. Okay, next bit, we want y less than or equal to x. Get a different colour. So for this one, that's y is equal to minus x, because you want it less than or equal to, it's below your line. If it was bigger than or equal, it'd be above your line. And the final colour. This is y is equal to a half x plus 1. We want y bigger than. So because it's bigger than, it's above the line you want. That's all of this here. And then can you see on my diagram which bit's been shaded 3 times? It's this section here. So that's where you need your region R. Okay, next question. Factorize. So this is a double bracket in disguise. Hopefully you're recognizing this as a dots question. It's difference of 2 squares, because you can square root both of them and it's a difference. Square root of 9x squared is 3x. Square root of 4 is 2. I need a plus and a minus. Right, we've got a quadratic equation here to factorize. Again, you may have been given, there's quite a few different methods to factorize a quadratic when the coefficient of x squared is bigger than 1. I'm going to use the splitting down the middle method, because I feel like that's the most common, but you might use the trial and error method, or you might use a grid method. I'm going to split down the middle. I'm going to factorize this first. So hang on, let me put it equal to 0 after once I've factorized it. So a times b, I need 2 numbers that multiply to give you 3 times minus 8 is minus 24. So you always do this multiplied by this. I need 2 terms that add to give minus 2. Okay, so I know one's positive, one's negative. I'm thinking it's something to do with 6 and 4. It's minus 6 plus 4, because minus 6 multiplied by 4 is negative 24. Minus 6 plus 4 is negative 2. I'm going to split this term here then. 3x squared minus 6x plus 4x minus 8 is equal to 0. Then I'm going to factorize here into a single bracket, 3x bracket x minus 2. Here, I'm going to factorize this into a single bracket, 4 bracket x minus 2. If you want any videos on any of these methods, we put a little message in the YouTube. I can link you up with a video to watch these different skills. And first bracket is 3x plus 4. Second bracket is x minus 2. But we need to solve it as well. So this multiplied by this is equal to 0. So x equals 2 would make sure this bracket is 0, wouldn't it? Because 2 take away 2 is 0. That's one of your answers. Let's have a look at this one next. I'm going to put the whole bracket equal to 0 first. Then I'm going to take, don't give you much space here, take 4 off both sides to get 3x is equal to negative 4. Divide both sides by 3 to get x is minus 4 over 3. If you put minus 4 over 3 as your x here, that bracket would equal to 0. Okay, next question. Solve. Start by multiplying both sides by 1 minus 3x. I'm going to leave it in a bracket. Expand your brackets. Balance out your x's. I'm going to add 6x to both sides. Add 10 to both sides. Divide both sides by 8. I'm just going to, I think, yeah. Hang on, let me just simplify it first. I'm going to see what they will give you in terms of the answer. It doesn't say to simplify it, but I'm going to. 6 over 4, 3 over 2. So you might have 3.3 over 2, 1 and a half, 1.5. I'm going to put 1.5. Let's see what they give it you. 4, 1.5, 1 and a half, or 3 over 2. Oh yeah, for 4 marks, you could have had 12 over 8 or 6 over 4. Okay, so 16a, work this out. So this 3 represents a third there, doesn't it? So 64 to the power of a third squared. That's how you need to be thinking it as 64 to the power of a third, then squared. So when you power by a third, it's the same as cube root. It's a cube root of 64 squared. Cube root of 64 is 4, because 4 times 4 times 4 is 64. And then 4 squared is 16. Hopefully you were looking at this one and thought, well, it's recurring decimals into fractions. This is quite a nice, easy one to do. So if you remember this one, something along the lines of let an x equal 0.131313. It recurs twice. It's a double-digit recurring number, so I'm going to times it by 100. I write this above because I'm going to subtract them. If it was a single-digit recurring, you times it by 10. Right, I'm going to line these place values up correctly to see that when you subtract 100x, take away 1x is 99x. This line, take away this line. Can you see all of these would disappear to make 0, wouldn't they? So you'd be left with 13. X is 13 over 99. Divide both sides by 99. Okay, now we can write it like this. Might make it a bit easier because everything's now a fraction. It's like it's at least in the same form, isn't it? So how do we make P over Q the subject? I'm going to take 13 over 99 from both sides. Oops. Oh, sorry, that's 99. Okay, so we need to, when we're subtracting fractions, we need a common denominator, which I'm going to use as 99. Because 99, the lowest common multiple of 9 and 99 is 99. Okay, so this second fraction is already out of 99. I'm going to multiply that by 11. Okay, let's just do that subtraction now. 55 take away 13, 42 over 99. Okay, so P is 99, 42 and Q is 99. Sorry, I've just looked at the mark scheme and I haven't put it in its lowest terms, have I? Okay, sorry about that. So how do we get this in our lowest terms? We need a common factor of both of these numbers. Let me just think. I'm guessing it's 3. Yeah, that's it. If we divide both sides by 3, with both of your numerator and denominator by 3, you might want to do a little bus stop method here. 14. And 99 divided by 3 is 33. Coordinate geometry. So a rhombus. What is a rhombus? It's a parallelogram, all the sides are the same length. These properties of the shapes are quite important with these types of questions. These are parallel, but all those sides are the same length. One diagonal of the rhombus has equation y equals half x plus 3. So got a positive gradient here. So this diagonal here, I'm going to say is y equals half x plus 3. The other diagonal passes through the 0.17. I'm going to call this coordinate here 17. Could have called the other coordinate 17. It doesn't really matter. Let me just change the colour on this for a bit. Find the equation of the other diagonal of the rhombus. Give your answer in the form y equals mx plus c. So you need to know for this that the diagonals of a rhombus or parallelogram cross at 90 degrees. So my gradient of this diagonal here is a half. To get the gradient of the perpendicular, it's the negative reciprocal, isn't it? It's a negative reciprocal of the gradient of the other. So -1 divided by a half. Not got a calculator here, have we? So you can have to do our keep flip change again. 2/1 is 2, which is -2. So the gradient of that perpendicular there is -2. So we know for this diagonal here, the gradient is -2. I'm going to put that in the general form of the equation of a line, y equals mx plus c. Right, now, we know a point that lies on this line here is 1, 7. So here x is 1, y is 7. I can substitute that into here. So y is 7. -2 times 1 is -2. I can add 2 to both sides to get 9 is c. So your y-intercept would be 9. So your equation is y equals -2x plus 9. Ooh, this looks like a nice complicated one here. So I'm going to write these as fractional powers first, I think. 5th root squared, so to the power, 5th root is the power 1/5. And then we got 1/5 squared. I'm just going to write it like this first of all. And this is the cube root, so it's power 1/3 squared. So they're both squared, aren't they? I can square root both sides, which just gives me the power 1/5 and power 1/3 here. Okay, now, like if it was square root, to reverse a square root, you square it. To reverse a cube root, you cube it. How do you reverse a 5th root? You power 5. I'm going to power 5 both sides. I'm going to put that as an extra step here. How do I, what do I do with my powers here? My rules of indices, I multiply the powers. A 5th times 5 is just 1. So it has, you can see there, it's just kind of reversed it. 1/3 to the power 5. 5 times 1/3 is 5/3. can you see x? I've got it in this form. X is 5/3. That was quite a tricky one. I wouldn't expect many people to get this right on the paper. How many questions? Oh, 2 questions left, I think. Box contains 25 discs in the ratio 4:1. 5 parts in total. 25 divided by 5 is 5. 5 times 4 is 20. So we've got 20 blue, 5 yellow. 2 discs are chosen without replacement for the box. Find the probability that the 2 discs are different colours. So different colours would be a blue and yellow, or a yellow and blue. You could pick a blue and then a yellow, couldn't you? You could have different colours. Or you could pick a yellow and then a blue. Probability of a blue than a yellow, and it's without replacement. So which is blue here? Blue is 20. So we've got 20 out of 25 times, what's the probability of a yellow? Be 5. It'd be out of 24, wouldn't it? Because you've taken one out. Okay, next bit. We have yellow or blue. Yellow is 5 out of 25. And then blue is 20 out of 24. We just simplify these to make them a bit easier to deal with. Okay, 20/25, we're just dividing both sides. So we're simplifying by dividing both by 5, gives you 4/5. 5/24 cannot simplify. 5/25 is 1/5. 20/24, common factor of 4, so 5/6. A bit easier to work with now. I'm going to cross simplify first. Divide the top left and bottom right by 4. Okay, that wasn't too bad. 1/3. Sometimes these probability ones are quite difficult, but I think that was accessible, I think. Just make sure it's correct. What question are we on? Yeah, 1/3 or equivalent. So you could have had an equivalent fraction as long as it's simplified down to 1/3, then it's fine. Okay, vectors. OB. Okay, so this is a parallelogram. So this vector here from A to B is just C, isn't it? And the vector from C to B is just A. OB, to get to OB, it's OA plus AB. OA is A, AB is C. So just A plus C, or C plus A. ON. There's my journey from here to here. Right, N lies on AB, such that AN to NB is 3 to 5. So this is 3/8. There's 8 parts in total. This is 3/8 along that line. Let's just put that 3/8 there. So it's 3/8 of C. This is 3/8 of C from A to N. N to B is 5/8. So O to N equals O to A plus A to N. O to A is A. A to N is 3/8 of C. That's your short answer. Cannot simplify it. The line C. Hang on. Let me snip this just so I can read at the same time. Okay, the line CN. I'm going to write my answer up here. The line CN is extended to reach the point P, such that CP equals 8/5 CN, right? Using vector, show that OAP is a straight line. So we're assuming P is somewhere over here. Well, we don't know that it's a straight line yet. We've got to show you using vectors is OAP, CP equals 8/5 CN. I need to write that down. So I'm going to just try and fit my answer in here. I'm actually right on here, you know. To show this is a straight line, I'm going to find OA, sorry, and AP. You could have found OP and OA or OP and AP, as long as you find them correctly. But you can see if you find them correctly, because we're going to see that they are on a straight line. So O to A, it's just A. A to P is O to A. Right, we're going to have to find, we don't know this A to P, so we're going to have to find a different route around. O to P is O to C plus C to P. Right, okay. O to C is C, and C to P is 8/5 C to N. What is C to N? No, we haven't found that. C to N, I'm going to put up here, is C to B plus B to N. CB is A. BN, but we're going to have to minus it because we're going the wrong way through our arrow, is 5/8, so minus 5/8 of C. So we've got C plus 8/5 of A minus 5/8 C. I'm going to expand these brackets here. 8/5 A minus, right, 8/5 times 5/8. 8 times 5 is 40. 5 times 8 is 40. So I got 40. Oh, sorry, I've got a C as well. Hang on. Oh no, that's, I don't know why I put that bracket there. Sorry, that bracket should be here. C. 40 over 40 is 1, isn't it? So I've got C plus 8/5 A minus C. C take away C is 0, so I've got 8/5 A. Right, so now you can see if OA is A and AP is 8/5 A, this is a multiple at 1 point, so it's 1 and 3/5 of this. They're a multiple of each other, so we can say they're parallel. So OA and AP are parallel. And it's because one is a scalar multiple of the other. It's because AP, I haven't got any more space for this. Let's go up here, is a multiple of OA. Now, how do we show they lie on the straight line? They've both got A in common. They both have A in common. Because they're parallel and they have a letter in common, therefore lie on a straight line. I should say lie. Oh, sorry for squeezing this in. Okay. I think that's it now. Let's have a look. Yep, end of question paper. Okay, hopefully you found that useful. Thanks for listening.